Here is a pattern that breaks almost every application at scale. Your homepage loads a product catalog. Database query: select all active products ordered by popularity. Takes 80 milliseconds. Runs once. Fine. Now 10,000 users visit your homepage in 1 minute. That same 80 millisecond query runs 10,000 times. Your database connection pool saturates. Queries start queuing. Latency climbs to seconds. New connections are rejected. The homepage stops loading. Here is the thing. That product catalog did not change in those 60 seconds. You ran the same query 10,000 times and got the same result every time. You paid the database 10,000 times for data that was identical throughout. Redis fixes this at the root. Run the query once. Store the result in Redis. The next 9,999 requests get the answer from memory under 1 millisecond. Your database sees 1 query per minute instead of 10,000. It runs cool. Your app runs fast. Azure Cache for Redis is a fully managed Redis service. Microsoft handles the infrastructure, patches, backups, monitoring, failover. You get a Redis endpoint and start using it immediately. The tiers matter depending on your use case. Basic, a single node with no SLA. Use it for development and testing only. Standard, a primary with a replica. Automatic failover. 99.9% SLA. Use for production. Premium, adds persistence to disk, Redis cluster for horizontal scaling, geo-replication. The persistence option on Premium is worth understanding. Redis is an in-memory store, data is lost on restart by default. With persistence, Redis takes periodic snapshots to disk. If the instance restarts, it recovers from the last snapshot. Use this for session data or any data you cannot afford to lose on a restart. And the geo-replication on Premium lets you replicate your Redis instance to a secondary region for disaster recovery, the same pattern as Cosmos DB. Cache-aside is the most widely used caching pattern and the safest. The logic runs in 3 steps. Step 1, check the cache. Is the product catalog in Redis? Step 2, cache hit, return the cached data immediately. Done. Step 3, cache miss, query the database. Store the result in Redis with a TTL. Return the data. The TTL, time to live, is the key to keeping data fresh. Set it to 5 minutes. After 5 minutes, Redis automatically deletes the cached item. The next request is a cache miss. The database is queried again. Fresh data is cached. But here is the mistake most developers make. Setting the TTL too long. Product prices change. If your cache TTL is 24 hours, a price change takes 24 hours to reach users. Match your TTL to how often the data actually changes. Product catalog, 5 minutes. Homepage banners, 1 minute. User profile, 15 minutes. Cache-aside also degrades gracefully. If Redis is down, your application queries the database directly. Slower, but the app keeps working. Redis is a performance layer, not a critical dependency. There is a famous saying in computer science. There are only 2 hard problems, naming things and cache invalidation. Cache invalidation is hard because your cached data and your database can disagree. The simplest approach, TTL expiry. Accept that cached data is up to X minutes old. For most data, product catalogs, blog posts, user feeds, that is perfectly acceptable. No invalidation logic needed. The cache expires. Fresh data loads. Write-through caching is stricter. When a product price is updated in the database, immediately update the cache too. Cache is always in sync. Never stale. Downside: every write now touches both the database and Redis. More complex. More potential failure points. Explicit invalidation is the middle ground. When a specific product is updated, delete just that product's cache key. Next request for that product is a cache miss, fetches fresh data from DB. Other products' cache entries are untouched. My recommendation: start with TTL expiry for all new caches. Only add write-through or explicit invalidation when you have a specific staleness problem. Avoid over-engineering cache invalidation before you have proven you need it. Here is a scaling problem that Redis solves completely. Your app has a login session stored in memory on server 1. User makes the next request, load balancer sends it to server 2. Server 2 has no memory of the session. User is logged out. This is the classic horizontal scaling problem with in-memory sessions. Redis session storage fixes it in one step. Every app server stores and reads sessions from the shared Redis instance. User on server 1, next request on server 7, same session, seamlessly. ASP.NET Core, Spring Boot, Express, Django all have Redis session providers. Point them at your Azure Cache for Redis endpoint. Sessions are now shared, persistent across restarts, and scalable. And here is the security benefit. Set a session TTL of 30 minutes of inactivity. Idle sessions are automatically deleted from Redis. No manual cleanup. No sessions lingering forever. Expired sessions force re-authentication, standard security practice. Redis is more than a cache. Its data structures unlock several use cases. Hashes store objects field by field. Instead of serializing a whole user object, store each field separately. Update the user's last login time without touching the rest of the object. Efficient. Atomic. No overfetching. Sorted sets are perfect for leaderboards. Each member has a score. Redis keeps them sorted automatically. Add a new game score, ZADD leaderboard 9500 player_ID. Get top 10 players, ZRIV range leaderboard 09. This query is login, blazing fast at any scale. Rate limiting with sorted sets is a common pattern. Store request timestamps in a sorted set per user. Count how many timestamps exist in the last 60 seconds. Above the limit, reject the request. Old timestamps expire automatically. Pub/sub turns Redis into a lightweight message bus. Publisher writes a message to a channel. All subscribers on that channel receive it instantly. Use this for live notifications, real-time dashboard updates, and chat features. Not as reliable as service bus, messages are not persisted, but fast and simple. Let me give you the practices that prevent production incidents with Redis. First, memory management. Redis keeps everything in memory. If you do not set a max memory limit, Redis will use all available RAM and the server will start swapping to disk. Performance collapses. Always set max memory. Set the eviction policy to Wakizaru. When memory is full, evict the least recently used keys automatically. Second, monitor your hit rate. A cache hit rate below 80% means most requests are going to the database anyway. Your TTLs may be too short. Your cache keys may be too granular. Review the caching strategy. Third, connection pooling. Creating a new Redis connection on every request is expensive. Use a connection pool, create connections once, reuse them. Every major Redis client library supports this. And here is the mistake that silently degrades performance. Caching entire large objects, 500 kilobytes serialized blobs in a single Redis key. Serialization and deserialization at that size costs more time than you save. Cache smaller, more targeted data. Use Redis hashes for objects. This is part 27 of the Azure series. Subscribe and keep going. Next up, Azure CDN. Let me bring it all together. Azure Cache for Redis sits in front of your database as a high-speed memory layer. 100,000 operations per second. Sub-millisecond latency. The same query that your database answers in 80 milliseconds. Redis answers in under 1 millisecond. Cache aside is your default pattern. Check cache first. Miss? Query the DB, store the result, return. TTL handles freshness automatically, no manual invalidation needed for most use cases. Redis Session Storage solves horizontal scaling instantly. All app servers share sessions through Redis. User sessions survive any server restart or load balancer decision. The data structures open up leaderboards, rate limiting, pub/sub, and activity feeds. All without a separate specialized service. Use the standard tier for production, primary plus replica with automatic failover. Premium if you need clustering, persistence, or geo-replication. This is part 27 of the Azure series. Subscribe and keep going.